Okay, so today we're looking at graphs of functions with combined transformations. So our learning intention is to gain the knowledge in translating and dilating functions and using this to calculate key features. So we'll be successful if we can correctly calculate and apply the correct translation and dilations, and if we can use that to find key features such as turning points or axes of symmetries or x-intercepts. Okay. We want to sketch the graph of the transform function if x squared is transformed to y equals x minus 1 all squared plus 3. Okay. And I'm going to do this, I've done this with a couple of graphs to start with. So, so this is our parent function of y equals x squared. Okay. I'm going to apply the horizontal transformation first because it's got no horizontal dilation of 1. So I'm going to translate it to the right by 1 unit. So that x is 1. So this point now sits on 1. Yeah. So this is what's happened. It's gone there to now become 1 0 from 0 1. Sorry, 0 0. So everything's shifted over. I'm then going to create a horizontal dilation of 4, which will make the parabola narrower. Yeah, so such as, what's a good point here? So this point here was 1, 2, 3, 4. And what's happened, so 3, and it's shifted it all up. 4 times 4 is 16, so it's up here. Yeah, so that's point now become 316. Okay, this has still stayed at 1 0. Okay, and then the last part I'm going to do is shift everything up by 3 units. So this point is going to go up 3 units and be somewhere there. Okay, so what we have is we have the 1, 3 is our turning point. Our axis of symmetry is x equals 1. And from there we can find other points. Okay. So let us look at doing this. Yeah, we'll come back to that question in a very second. Let's do this one. Let's translate x cubed and it's transformed to become this. So automatically, I've already filled in the parent. Okay. What I'm going to do, so there's no horizontal dilation, but what I'm going to do is translate it all to the left by 2 units. Okay, so the x plus 2 all cubed. So if you had 0, right, 0 plus 2, and then you cubed it, would give us 8. Yep. The 1 would give us 27. The 2 would give us 64. The 3 would give us 125. Obviously, this is beyond my graph. That's okay. Minus 1 would give us 1. Minus 2 would give us 0. Okay. So see how it's shifted 2 units. So this is going to be negative 1, and this would be negative 8. If I was to draw that, okay, oh sorry, that's still y. These are all our y's. Okay, so we get at negative 3, we get negative 1. So it's shifted this point across to the left by 2 units. Negative 2 becomes 0. Negative 1 becomes 1. And 0 becomes 8. Okay. And because I don't really want I don't want this to be the final, the stopping point, I'm just going to make it with dashes. And I try to keep it as parallel as my parent graph. So the next thing I'm going to do is I'm going to have a vertical, so that was the horizontal dilation, horizontal transformation. I'm now going to do the vertical dilation and then the vertical translation. So the vertical dilation is a half. So what I'm going to do is I'm going to halve all these values. Um, 27 divided by 2. Okay. So I might do this in pencil. So it's going to compress the function. So 0, 0 stays the same. And 0 becomes 4. Okay. Something like that. And then it's going to everything's going to shift down by 2 units. This becomes 1, 2, 1, 2, 1, 2. Sorry. So this is y equals a half x plus 2 cubed minus 2. Let me just highlight that one just to say that's the one I'm wanting. Okay. So, thinking back to this y equals x squared and we transform it to 4x minus 1 all squared plus 3, okay, and I showed you how we transformed it. I just want you to notice that this function here, okay, so there's my original parabola. I then translated it to the right. I then vertically dilated it and then vertically translated it. Okay. If I was to horizontally translate it, okay, and then had a horizontal dilation, okay, and then shifted it up, okay, that's very different to this. The functions do produce different graphs. Okay, so be conscious about where this 4 is hanging out. Okay. All right. So let us look at this one. For a function of y equals f of x with turning points as shown. So we've got some turning point here at 0, 2 and 3, 0. I've got an x-intercept of -2, 0, and I've got just a point, hidden point of -4, -3. We want to sketch the transform function if it's vertically dilated with a scale factor of 2, translated down by 4, so we get a vertical translation as well, and then horizontally translated 2 units to the left. Okay, so we're always going to do the dilations first. Scale factor of 2. So what that means is going to multiply the y coordinate by the scale factor. Alright, so -3 times 2 gives us -6. Because there's a couple of things, I'm just going to probably do this in pencil. So -4, -6. This would still stay at -2 and 0. 2 times 2 is 4, so this now becomes 0, 4. And this will stay at 3, 0. Okay, so it looks like that. Okay. Then we're going to do, so we did the dilations, now we're going to do the translations. So vertical translation is next. So down by 4 units. So we're going to subtract the y coordinates. Or we might want to say we can add the y coordinates. Because of -4, then it will come down. So should we add so we're going to go down 4 units, and that becomes 1, 2, 3, 4. So that's going to be -4, -10. This is going to go down 4. So here we're going to go down 4 units. So we now have -2, -4. This now becomes 0, 0. This becomes 3, -4. So we get something that. Now we want to horizontally translate it 2 units to the left. So we're going to, we've got a horizontal translation. So we're going to, as we're going to the left, the x coordinates change. Because I'm going to the left, we're going to go 2 units. Yeah. So this point here is actually going to be negative 4. So these are my final points, so I may as well do it black. Or do it blue, actually. Negative 6 and negative 10. Okay, so this point ended up becoming negative 6, negative 10. Yeah. This is going to go to negative 4, negative 4. This point's going to go negative 2, 0. This is going to go to 1, negative 4. So we have something that looks like that. And then you can rub out all the unnecessary graphs and necessary points. Okay. So we have a function that has a stationary point of 6, 1 and 3, 2. We want to find the images of these points if the function is transformed to this. Okay. So remember that this is now your vertical dilation. This is your horizontal dilation, and that is your vertical translation. Okay, so we're going to start with 6 and 1 and negative 3, 2. Okay, so what I'm going to do is I'm going to definitely do the horizontal dilation first. So that's going to affect my x coordinates. So it's 3, so I'm going to have a scale factor of 1/3. Giving me 2, 1, negative 1, 2. Okay, I've got no horizontal translation, so that's okay. I'm then going to apply my vertical dilation. Okay, and that's going to affect my y. So what I'm going to do is multiply it by negative 2. Yeah. So it's going to give me 2, negative 2. And the new change is going to give me that point. And then I'm going to do the vertical translation. So my x coordinate stays the same, but now I'm going to add 1 to my y coordinates. My x coordinate stays the same. I'm going to add 1 to my y coordinates. So I end up getting to 2, negative 1, and this is going to become, so I get 2, -1, and then I also get -1, -1. Okay, applying the transformations. Okay, thank you very much.